Hello everyone, this is Aditya Sharma and welcome back to yet another tutorial video. As you all might have seen already, our topic for today is flood fill algorithm. Before diving into the algorithm, let us discuss about color filling. We've all used MS Paint in our school days, right? Given any shape, we select the bucket icon, we choose our color and we click on the object within which the desired color is meant to be filled. As you can see on the screen, we have a square object, and what we usually do in MS Paint is that we click on the bucket icon and choose the desired color that we want to fill in the square. Later then we go to the object and click within its boundaries, and thus the color gets filled. It all happens so instantaneously that we couldn't even recognize how it got filled. But in technical terms, with the perspective of computer graphics, it's essential to understand how actually the object got filled with that color. The answer is using flood fill algorithm. Flood fill is probably most commonly known as the bucket fill application algorithm. It is widely used in most of the art programs. It's usually indicated by a bucket icon that looks similar to a paint bucket and is known to fill in any enclosed area, as I showed earlier. Flood fill is essentially composed of two parts: selecting the pixels and filling up them with the desired color. From the perspective of computer graphics, the goal is to simply select the pixels and plot them with the desired color. We have for a pixel can have a total of 8 neighbors or 8 connected components around it, like left, right, bottom, up, top left, top right, bottom left, and bottom right. There are two sub-algorithms that are used to ensure that flood fill is completed. These are BFS and DFS algorithms. These algorithms decide which pixel to select first and in which order the color will be filled. Let us look at the algorithm's syntax of flood fill algorithm. Here we use inbuilt functions getPixel to get the current properties of pixel and putPixel to fill a pixel with a specific color, and I and j represent the coordinates of pixel. The fundamental concept of recursion is used here to trace all the neighbor pixels in all the 8 directions. These 8 recursive calls represent the traversal in all the 8 directions. To simplify it, let me elaborate it using highlighter. This recursive call represents the traversal in downward direction, this one in the upward direction, this one in the rightward direction, this one in the left direction. This traversal signifies bottom right direction, this one signifies top right direction, this one represents bottom left, and this one represents the top left direction. Thus, we have represented the traversal in all the 8 possible directions. Thus, these 8 recursive calls help to traverse and fill the color in all 8 directions. Now let us understand the DFS visualization to understand the concept of flood fill using an animation. Here we are trying to fill peach color in a circular shape having red colored boundary. The biggest advantage of flood fill algorithm is that the color of boundary does not matter when filling the color. The boundary could be composed of multiple colors. Here, for simpler understanding, I have took red colored boundary. Let us have a look at this animation once again. Starting with the central pixel, the DFS algorithm tends to fill color in one direction only until the boundary is encountered. As you can see, once the boundary is encountered, the direction of filling the color gets changed. One must keep in mind that the pixel that is already colored or the pixel that is already visited must not get visited or reached colored again. Let's see the animation again. We start from center pixel, we start filling in the right direction, and as soon as we encounter the boundary, we change the direction and we continue to fill pixel in different directions. Through this, we gradually fill the object with peach color. This is how the DFS algorithm works. Now let us understand the visualization using BFS algorithm animation. Here, the goal is to travel in all the 8 directions simultaneously. Starting from the center pixel, we uniformly travels in all the 8 directions. This depicts a spiral pattern of fill in the color. Let us have let look at this animation again. As you can see, starting from central pixel, the object is getting filled in a spiral manner. So this is how the BFS algorithm works, and this was the representation and visualization of the BFS algorithm. We've understood how DFS algorithm works, and now we understood how the BFS algorithm works. That was all about the flood fill algorithm and its visualization. If you found this explanation useful, do consider dropping a like. Thank you very much and have a good day.